Let's solve this question. A sequence of real numbers from a1, a2, a3 to an satisfies the relation an plus 1 plus an minus 1 is equal to 2 into an plus 2 raised to the power n for all natural number values of n greater than 1. If a1 is equal to 5, a2 is equal to 13 and a36 is p plus 2 raised to the power q, then find the value of p plus q where p and q are positive constants. So a sequence of real number is given from a1 to an that satisfies this relation. This relation is an plus 1 plus an minus 1 is 2 times an plus 2 raised to the power n. If I rewrite this relation, I can write it as an plus 1. An plus 1 or n plus first term is equal to 2 times its previous term, that is an, minus yet previous term, that is an minus 1 plus 2 raised to the power n. So this sequence of real number follows this relation, and the value of a1 and a2 is given as a1 is given as 5, a2 is given as 13, and it is asking me to find the value of a36, and a36th term of this sequence can be represented as p plus 2 raised to the power q. So the idea is I have to I try to represent all these terms a1, a2 in this format, that is p plus 2 raised to the power q. So I can write a1 as in this format as 1 plus 2 raised to the power 2. Next, I will try to try to write a2 in this format only. So I can write 13 as 2 raised to the power 3 plus this is 8 and 5, 2 raised to the power 3. And the further terms, that is a3, a4 and a5, I have to find these terms by using this relation. So if I put n is equal to 2, I get the value of a3. It becomes a3, and a3 is equal to 2 times a2, that is previous term, minus a1 plus 2 raised to the power 2. So I can find the value of a3 because I have the value of a2 and a1. So it becomes 2 into 13 minus a1 is 5 plus 2 raised to the power 2. So a3 becomes 26 minus 5, 21 plus 4 is 25. So let's just try to write 25 in this format. So yes, I can see the pattern that power of 2 is increasing by 1. And indeed, I can write this a3, that is 25, in this format, that is sum of 2 raised to the power 4 plus this is 16 plus 9, 25. Now, we can observe that power of 2 is increasing by 1, and this series is nothing but an AP with a common difference of 4. This 1 has increased by plus 4, 5 has increased by plus 4. So according to this pattern, the value of A4 must be equal to 13 plus 2 raised to the power 5, because power of 2 will increase by 1 and this term will increase by 4. So let's just find out that A4, and according to this pattern, A4 will be 32 plus 13, that is 45. Let's just find out the value of A4. So if I put n is equal to 3, I get the value of A4 as A4 is equal to 2 times its previous term, that is 25, minus yet previous term, that is A2 30, plus 2 raised to the power 3. So this is 50 minus 13 plus 8, and which is indeed 45. So yes, A4 is 45. So I can say all these terms are following this pattern. So I can write the nth term of this series as first term in this first place, or this first term in this nth term would be governed by the nth term of this AP, that is 1, 5, 9, 13 with a common difference of 4. So I can write it as 4n minus 1. Why? If I put n is equal to 1, I get this is 3. I can write this general term of this AP as 4n minus 3. So if I put n is equal to 1, it becomes 1. If I put n is equal to 2, so 4 into 2, 8 minus 3 is 5. If I put n equal to 3, I get 9. Plus 2 raised to the power, I am getting in each term, 2 is having power just 1 more than the number of term. So if it is second term, then power of 2 is 3. If it is third term, power of 2 is 4. So I can say if this is nth term, power of 2 would be n plus 1. According to this general term, I can write 36th term as 4 into 36 minus 3 plus 2 raised to the power 37, which is equal to 36 into 4. This becomes 144 minus 3 plus 2 raised to the power 37. So it becomes 141 plus 2 raised to the power 37. And it is given me as p plus 2 raised to the power q, where p and q are two positive constants. So comparing these two, I can say I am getting p as 141 and q as 37. I need to find the value of p plus q. So p plus q becomes how much? This is 178. So correct answer to this question is 178.